Let's continue our discussion with C++ STL, that is Standard Template Library. We have seen about sequence containers, and this is adapter containers. The adapter containers, they are called because they adapt. The name is adapt to the interface of another class, and they are not implemented as such, means from the beginning or from the scratch. They have very special and restricted functionality. The three adapters in STL are the first one is stack, the other one is queue. This T is nothing but the data type. Wherever you see it, just understand that I'm talking about any string which can be, or any data type, any integer can be passed, or it's a universal thing for any data type. The third one is the priority queue, and we are going to see about this. Associative containers, these are the containers, unlike the sequence containers where we were accessing elements by their position or their index. But in these associative containers, we only know, or we only want just to insert, remove, or look up elements, but we are not worried about how they are stored, as long as this data structure can find them by themselves and based on some identity or key whenever we want to access them. So we have seen this set and map. These are the two associative container types, these types. Just recall that set T, we have already discussed it. So this T, this is data type, set insert data type something. So we have this insert, remove, and bool, that it contains or not. So insert, remove, and contains, these are the three functions which are related to set, where in this map case, map, or we call them a dictionary somewhere also, these are similar, but it produces an association key. So you have a key and a value pair. For example, you have a word and the definition of word. So word will be the key and definition of word will be the value. And the name which is used in STL and elsewhere is usually map. So you can generally understand that map and dictionary are somewhat synonymous in context of your data structures. These are the functions which are generally related with our map or dictionary. One is insert. You are inserting a value which is related to this key. You are removing the value which is related to this key, and you are also looking up, you are finding up this value. So while this is how we have been thinking about the sets and map, but the implementation we are going to see, there are various set and map classes. STL actually provides us implementation of this set and map, but they differ in several parameters. For example, set, and for example, set you have like this, and you have some integer. Okay, the set of an integer. This says that it is of a data type. Now what it does, it implements a set that contain at most one copy of each element. In your high school mathematics, if you can recall, set cannot have values which are duplicate, but we have multi-set also here, which implements a multi-set of element which allows multiple element with similar key. While in this map, where you have, or you can say some multiple element, but map, you have key and value pairs. So this map function, it implements a map from keys to values, confirming that there is at most one copy of each key. So each key will relate to only one and one type. But multi-map, just you can have a map, say map plus multiplicity. It is equivalent to map, but you are allowed to, it implements actually a map for keys to values that allows the data structure to contain more than one copy of a key. But there is a very interesting thing behind all these different set map classes. They are implemented using BST, that is balanced search tree. We are going to see a lot about this in later session. What this means, BST, is that you will have to provide a comparison operator, that is less than, equal to, less than, for your type T, if you want to use these types. And there is an alternative implementation also. You, rather than BST, you have this hash tables. We are also going to see this in later session. To access those implementation, you put the word unordered in front of this type's name. So whenever you try to do this implementation, you prefix a word called unordered in front of map. This hash table implementation is often very fast, means quicker, but actually this hash thing depend entirely on your hash function. If your hash function is good, then you'll get things very faster. But on the other hand, this tree based version is also fast at iterating all entries in sorted order, since that's how they are stored internally anyway. These are the function in STL set map classes, and these are the relevant functions for set. That is set, you insert element. This inserts the element into the set, and also it returns an iterator to the element, but this is usually not so relevant right now. Then you have a function called set erase. It removes the element from the set. Then you have set count, and you have element here. In all these three functions, you have the parameter as the element, so you are counting the element, but it returns the number of times the element occurs in the set, which is generally 0 or 1 for a regular set. But multi-set, it will not be there because there will be multiplicity. And this allows you to test if set contains the element or not. That is, set find, it returns an element to the element in the set, iterator to the element, and you can use this for removing the element. But if the element is not in the set S, the iterator will be equal to S end. Hope you can understand this, because if it is not there, this is a set, there are various elements. If you do not find an element, the iterator reaches to the end point. And for maps, for these maps, we have we had written add as a function with two parameters, because we have key value pair. The way it is actually implemented in STL is with just a single parameter, which is just type pair. So a pair is just a structure of two individual types. Let me define that particular thing. You have a template. Say template already. The template is a framework, is the base in which you can insert, and it is reusable. So template, you have two classes, class S and class T. These are the class pair. Say you have this first as a type of or object of S, second as object of T. Then what you are doing, you are making a function passing these S and T, the objects of S and T, and you are assigning S to first and T to this second. So actually what you are doing is you are making something initialize. This throughout this list, we assume that we have a map which is key and value, and map insert you have key value. This inserts the association between your P first, this P first, and P second into the map, and returns an iterator to the element. So if the map already contained an association with this key P first, insert does not change anything because you already have an association. But it instead, what it does, it returns an iterator to the existing pair. While this map erase key type key, it removes the association from the key map, from the map. But there may be a case if there is no association for the key. If there is no association, it doesn't do anything. Then we have size type map count. What it does, it returns the number of association from the given key, which is 0 to 1 for regular map, and it is not so for multi-map because you have multiplicity. But iterator map, this find, what it does, because the return type is iterator, it returns an iterator to the pair key value which is associated with the key in the map. And if key has no association in the map M, the iterator will be equal to M dot N, because the same discussion goes on because values are not found, so it will be at the end. And the iterator iterates over pairs, different pairs. So if you want to extract the value, you can easily get it by M dot find key, then second, and then the key itself should be at M dot find key first. The first will be key, and then you can find easily the values. This is how to find the value. This is how we use this find function. Okay, but one more thing is that whenever you are, there was actually a mapping for your key before you difference the iterator, you must test it. Let me show you. This is an operator, and this is your trying to overload this operator, and it allows you to treat your map essentially like an array, because you're making an array by just writing things like how this works as an a type of operator overloading. So you are actually overloading it and making it available to allow you to treat your map just like an array. How? Make a map. You have a key value pair, then you name it a my map. Now my map, and because you have overloaded this, you can easily pass this string hello world, and you can assign a value of integer to this. My map hello world 103, my world some sentence with 42, and now you want to print my map hello world. But this is different from insert function. This one allows you to override the mapping for a given key, because what you have done is first you assign 101 to the key this string, then 103 for this particular string. So when you want to print this same, this 101 is overridden with 103. So the code, this will output as 103. So when you try to read the value for a key that isn't in the map, this will insert the key into the map with some dummy value assigned to it. It will then return the dummy value. Coming to iterators. Iterators means iterating, repeating things. Iterators are systematic and unified way of traversing arrays and other data structure, because you are actually going one by one with iteration. So just have a look how to use them. When you go through an array in a loop, your code might look like this. How? You are making an array and you are making a pointer I. Then what you are doing is you are taking the address of A to I. Now you have a address, I has an address. With each 10 value increment, because you are seeing that every time you increase A by 10, you increase I, and then you see out dereferenced I. That means you are printing the value. So you just notice that instead of writing AI, we basically treated the index itself as a pointer, like this. So iterator try to resemble this code as much as possible. When you have a data structure that implements or allows iterators, it will give you two functions, that is a begin and a end. The former one gives you an iterator pointing to the first element, and this latter one is an iterator pointing to the element just after you are done, which is after the loop a plus 10 is end. So you would write code something like this. My data structure something a iterator I. You will start with a. You will assign a begin, means the first address, to I, and you will go up till the end, and you increment I, and then you will print this star I, that is with dereference. So iterators usually overload is equal to, double is equal to, not equal to, and plus plus, and multiplication star, and this arrow, so that your code looks as similar as possible to the loop over the arrays. The convention of this a and means the things have ended. Therefore, when iterator is assigned map colon find, it returns an iterator. Its value will equal to nothing but m end, and if the element was not found and otherwise. It can be treated almost like a pointer to an array. But specifically, you use this star IT to get the pair that the iterators is pointing to. And this there are two versions. See, this is dereferencing, while this or this dot second, you are making like this star IT. This is inside. Then you are using this dot operator second or IT arrow second to reference to the second element, which is the value you wanted. You can also output the values in the map with similar iterator like this. You have a map. This is a key, this is value. You have a name called M now for a map. So you start with the iterator IT. You start with M begin. You end with M end and plus plus IT. And each time you want to have a key, you can do IT first. Each time you want a value, you just say IT second. So hope you got the bit idea about these iterators and STL, map and set, etc. Thank you so much.